Okay, let's work through this first problem here on the test review. Sodium has a +1 charge, phosphate has a -3, so we actually need 3 of the sodiums to balance out the -3 charge on the phosphate. And so its molecular formula is going to look like this. Whenever the problems talk about a solution, then just assume that it's an aqueous solution. Okay, and then the next aqueous solution is barium nitrate. Barium in the second family on the periodic table carries a +2 charge. Nitrate carries a -1 charge, so this is going to come together in a 1:2 ratio to balance out the charge. Remember, one way to think about this is if the numerical values are different, then you can basically switch the numbers, if you will, to get a properly balanced molecular formula. And since it is aqueous, then it is going to have an AQ with it. Right, and as we go through this, right, all of these are double displacement reactions. So the cation of one is going to pair up with the anion of the other. And since the two charges are equal and opposite, they're just going to come together in a 1:1 ratio. Now, sodium and nitrate are the two ions that are really common in these kind of metathesis reactions where you always get an aqueous solution. They're never insoluble. So I'm going to go ahead and tag that with the AQ tag. The second compound, the second product, this is a little bit different. We want to look at the solubility table, which we will in just a second, to see if barium phosphate is going to be a solid or not. Notice the ratio of the ions there. To balance everything out, like why do salt formulas have a particular ratio? Well, ultimately it is to balance out the overall charge. So I need 3 of the phosphates, would give me a +6 charge, and that's going to balance out the -6 charge on the phosphate. Now if I take a look at the solubility table from the lecture slides, remember the primary one that we want to look for is the anion. We're looking for phosphate. Phosphate isn't in the category for the soluble ions, so let's look at the insoluble ions, and sure enough it is. And what it's saying is that phosphate is typically insoluble, okay, or a salt of phosphate is typically insoluble unless it's one of these exceptions. And since barium is not there, that means barium phosphate is going to behave just like most phosphate salts, and it's going to form a solid. And so then we can then add that is the S for the solid. Now we need to balance this equation just like all the equations. When you have a bunch of salt formulas in your equation, if you're looking at the most complicated salt formula, oftentimes that will, and I see a typo there. Right, if you start with the most complicated, in this case the barium phosphate, oftentimes that will shorten your time while you're balancing the equation. So take the barium first. There's 3 bariums. There's only 1 in the formula here, so I need 3 in front there. Phosphate has 2 here, only 1 there, so I need a 2 in front. And notice what's happening here. The 2 times 3 gives me 6 sodium. The 2 times 3 give me 6 nitrates, and they're just going to come together in a 1:1 ratio to then finally give me 6 sodium nitrates sitting there in the product side. Now I can take this information and use it to figure out what the ionic formula or the ionic equation is going to look like. And I've actually got part of it sitting there. Basically what you do, right, if you have an aqueous solution, then you break each one of those ions apart. And so sodium phosphate would be represented this way in the ionic equation, keeping an AQ tag on all the ions. And I'm just distributing that to each of the ions in the salt formula. Going to do the same thing with the 3 in front of the barium nitrate. And then once they come together, I'm going to put the salt first, just out of habit. Right, it's the barium and the phosphate that actually chemically change during the reaction, and so they form a solid. You want to show them as a solid on all of the product sides here. Whereas if you have an aqueous solution, just like we saw on the reactant side, then we open those formulas up. And since I'm running out of room, I'm just going to squeeze it there below. And while I'm looking at the sodium and the nitrate, let me just point out, they are going to be the spectator ions in this reaction. They are the ones that don't change from one side to the next. And then finally, for the net ionic equation, you want to account for the product that forms. Well, that's simply barium phosphate. So I just pull the ions that are on the reactant side, including their molar coefficients. And now it's only the solid for the product side here. And that's it. We are done with the first problem here.